Welcome everybody at Vaarin for the third installation of TurkuAI CIC Talks Meetup. And I'm Jani Antonen from Vätsky, and we are the organizers of this meetup together with CIC. And we're a really old but still ongoing association that aims to gather all events and everything that's happening in ICT around Turku area. So welcome if you're interested in keeping these meetups or any other meetups in the area. So this is the meetup team. This is the supporting cast. He's not here tonight. Just got his second child, so he's a bit busy. But yeah, Jani Antonen and Kai-Mikael Björk. And today we have these three presenters with these three talks. And Jukka Heikkonen is first to go. But first, Kai-Mikael is going to tell you a bit about CIC, and then Vaarin is maybe
I can say a few words.
Showing something about them. But yeah.
Okay, hi everybody, thank you and welcome to CIC Talks. CIC is a Center for Intelligent Computing here in Turku. We have a very focused area, but we do like intelligent computing in many forms. And we try to support researchers around the city who is doing actively intelligent computing and AI related research. But today is our last series of the CIC Talks. It's a project that we obtained from Liedan Säästöpankkisäätiö, and we're very grateful for that. And they have helped us to enable researchers to go out to different kind of industries and gain some knowledge and maybe help them also at the same time to see where could they focus their effort if they want to implement AI solutions in the future. Of course, this project is not implementing it himself, but show the direction. Anyway, thank you from my behalf.
Right, so I won't bore you with any much detail, so I'll just ask the question, do you know who Vaarin is? Who knows what Vaarin is? Who's heard of Vaarin? Let's do vice versa, who hasn't? 1, 2, 3, 5, 6 people, not a lot. I'll just share a tiny bit here for you guys, for you 6. And if you want to ask any questions, go ahead.
Center for Security Research.
So, company CIC in Turku, or founded in here in the year 2000. We have the 25th anniversary where we go in Berlin next week to kind of celebrate that with everybody at the company. Why do we exist? We help to make those poor people who are using business applications that look like this, built with Swing, to look a bit more modern. So that's why we're here. We are basically building on top of open source, on Java stack. You can use Java, you can use React, TypeScript with the Vaarin tools essentially. I don't bore you with much of the details, so I'll just show you. Let's see there's that one slide, which I cannot find, so never mind, that's about Vaarin. So if you want to know more about Vaarin, ask me.
Okay. I just got a new computer, so I'm always uncertain how they work. But it seems to work very well. So the topic of my talk is forecasting restaurant sales. I'm Jukka Heikkonen, professor of computer science from Department of Computing. My field is intelligent systems, so it includes data analysis and machine learning type of topics. Both we developing my research group theoretical things, and we have quite many application projects and a lot of collaboration also with industry. So I can show something. Okay, probably I skip this. Probably you're more interested on these applications, what we have been dealing with during the years. we of course have this biomedical thing because University of Turku is very well known about biomedical studies. So there are a lot of things that we have support them. And especially recently, I have turned my research topics towards to these autonomous systems, sensor and data fusion. And there we are really interested on that, how from multi-sensor information we can guide these sort of unmanned vehicles, whether there's aerial or ground vehicles. And the interesting topic, of course, is this situational awareness, that the system should know what is happening outside of it and what sort of actions it can then make. And we are collaborative also with Ponsse, Patria, Finnish Defence Forces. Then I have had also some NATO projects, and now I'm applying some EDF projects also. Then some other interesting things like swimming analysis. A couple of years ago, we had the cameras in Impivaara swimming pool. Those who were swimming there probably has seen those. But of course, we only used those cameras when there was this swimmers that compete in swimming when they practice. Okay, this is shortly about that, some applications. So if you are interested of knowing more, just contact me. I will tell details. So let's go to this forecasting of restaurant sales, why it is important. Nowadays, of course, if you are planning your activities, no matter what sort of business you have to forecast, or it is important to forecast something based on the data what you have. And of course, when we are thinking about restaurants, it is important for decision making, like you optimize the inventory, you optimize what sort of stuff you are buying, and also what sort of stuff you need to serve the customers. And this is important that you should avoid over and understocking, because this overstocking may lead to the food waste. So that's probably one of the biggest reason. Then of course financial planning, you could estimate what sort of revenues or cash flow you could have in the, say, tomorrow or day after that, and etc. And then of course if you do some marketing decisions, you have to align these to the sales and also these promotions. There's some information in my slide. And competitive advantage, that you can adapt faster to market trends, and you are like better in the market than in your competitors. And important thing is the customer satisfaction, that of course that when you go to the restaurant, if a customer goes to restaurants, he or she is more satisfied if it gets a good service there, if there is enough stuff available. And especially if we have a volatile industry like we have this beachfront, seasonal beachfront restaurants or marina restaurants, then it's really important to estimate that what could be the sales for tomorrow, so that the restaurant owners could be ready for that. So in optimal sense, there are quite many factors that has to be considered, but in practice, only few of them exist, no matter what restaurants you take. Of course, you can collect from the open sources quite many of these, but it takes time, and some of them are very difficult even to, collect. One issue is the seasonality. Every time you are dealing with time series, you have to tackle the seasonality issues, like how the things are changing during the seasons, like summer or winter demand patterns, what they are like in holidays. Day of the week effect is very big, especially the restaurants, whether it's Monday or Sunday, weekend or weekday. Then you should also you should have also understanding of the promotions of the, like your competitions, theaters and also events, that and local happenings. If something big is happening there nearby your restaurant, you should also be aware of that. Then weather, like I mentioned, these beachfront restaurants, especially, they are very sensitive, the sales, for this sort of weather conditions. And of course, macroeconomic trends are these sort of things that they give the information how much money the customers may have. We all know that Finnish economy is really going down. This can be also seen on the sales of the restaurants. people just doesn't have enough money to go and eat so-called out to the restaurant. So this is time series prediction problem. This is rather self-evident probably for you, but I will also tell you the things that you are not probably aware of, what this means when we are dealing with time series. People normally, when they apply, say, machine learning methods or some more classical time series prediction method, they take the time series as it is and vet that to the system, and then they hope that they get the best result. But this is the wrong tactic, totally wrong. You have to do some sort of transformations for your time series to get the best possible type of prediction. It is temporal nature, of course, because the sales varies or data is collected over time, daily, weekly, and monthly. Dependency of past values, so of course the future sales could tell something about what could be the sale of the future. There are trends, historical patterns, and then you should recognize this sort of seasonality, holiday week, then trends, also this sort of periodicity that is happening in the time series, and better to remove or add those to the model. And final goal is of course to predict future sales using this historical data. But you may have also external type of things like exogenous variables like this weather type of things. Typical time series models, autoregressive models are probably the most classical ones. They are like this AR model, the really simple model, ARIMA, autoregressive moving ARIMA, and this ARIMA, which is an integration compound there. Those who are familiar with ARMA and this sort of Kalman filter, ARMA is actually exactly the same than this optimal linear prediction Kalman filter. It can be easily even proved. And if you have these sort of exogenous variables, of course you have this ARX or ARMAX or something like that. X just means that you have something else than just the time series itself. Exponential smoothing, it is actually infinite response filter type of things, as actually first order. I may tell some technical things you are not familiar, but I just go briefly about what sort of things. It's like a smoothing of the time series, where you weight more the most recent samples. And then you use this smoothing filter to predict the future. Why it works? Because time series normally has a very big autocorrelation between the samples. If I have some value at this time, I most probably has the more or less the same value in the next time instant. That's the reason why these sort of smoothing filters work. Then we have these recurrent neural networks like long short-term memory, gated recurrent, and a lot of something else also. But they require rather large data sets and more computation. And one potential one also that I have been testing here is this sort of random forest, like ensemble type of method. It's like a committee method. So it's actually this random forest is very good method in that sense that it in practice overcomes this overfitting type of problem. It also gives the information about the input variables, and it can deal at the same time with numerical and categorical variables. Okay, so some of the key components what often is neglected when starting to analyze the time series is the sort of trend, then this sort of seasonality and periodicity. Trend means that there's a longer term, say, increase or decrease of the time series, and like the sale is increasing during the years. That's one sort of trend. Then you may have this seasonality pattern. It's like some kind of regular type of change in the time series over certain intervals. Like you may have weekly seasonality, like Sundays you sell more Sundays than weekdays. Then is periodicity that may or may not be tied to seasons. And here you can see some of these components in one example time series, like trend, seasonality, periodicity. It's very important that you separate them while you are doing the analysis. Okay, here also you see that these sort of things. And after removing them, you have this residual or irregular component. It is called like stationary type of signal. Especially these autoregressive models, they in theory require that your signal is stationary. So why this is important, this sort of stationarity? So it means that the stationary time series signal has some statistical property that does not change over time, like this sort of mean variance and autocorrelation. So you have to deal with this sort of issue. If you just wet your time series to your model, you will not get that possible result. So why make it stationarity, especially if you apply this statistical model like AR model, autoregressive model, they assume that it's stationary. And also you can improve the predictability. So this stationary data makes patterns more stable and easier to extrapolate. And you also ensure model reliability and it also gives better parameter estimation. So how to stationary? The simplest method is you differentiate your time series. Like over here is the same thing. You take the difference. It's like a derivative of your time series at certain points. What is just here one example of it? That you have a time series with clear trend, you differentiate, you get the stationary type of things. Very basic stuff. Of course, it has some shortcomings. I will not go to detail on that. But it means that also that you are derending it, you actually remove the linear, say the linear part of your time series. You're like putting it zero mean type of level. And you do deseasonalize it, like you have some kind of cyclic type of model that you get, by which you get out of this seasonal effect. And then you can apply this sort of transformation like log, square root or box-cox, for instance, transformation. I will not go to detail on that. But this helps to stabilize the variance over time so that you have equal mean and variance in the time series through the time. So now if I go to the available data, what I processed, this is very typical case, like I was mentioning you that in the best case we have a lot of data from different sources, but normally if you take a contact to the company, first they are thinking that okay, we have a database, but who is even owning the data? I actually had one project with one company and they have actually bought a database system from other company. And then I even, because that was a consulting work I did for them, and I actually make even offer that how much it would cost to do this and this and this. But then they start to take a look at that, what sort of data they need, and they realize that they are not even owning the data. They have just they can just visualize, they can ask 10 questions per month for the database to visualize the thing. And we would have meeting tens of thousands of queries, which would have cost hundreds of thousands of euros. So no project, no money for me. So that's very typical thing after all. So this was 1 year customer data. There were customer accounts and sales with time. Then I did some data processes, like I added weekdays, features, also including the sales from the previous days, sales from the same week date, and time from the previous week. So I added some info, but not very valuable data. But of course, something has to be done because this was a preliminary study also to learn what should be done to get it better. And here's some visualizing. If you start the data analytics, no matter what you do, best thing is to learn the data first, and one thing is to visualize it. If you just take the data and feed that to your system, you don't know much about what the properties the data have, and you may not get that good results. So here is actually illustration of that. We have in x-axis there are these sales hour, so hour of the day, and then there is the customer count is in the y-axis. And then different colors actually they represent that what was the weekday, Monday to Sunday. And we see that there is actually rather a lot of variation, even if you look at the hourly customer count. You can also see the peak of the lunchtime there. So it has a quite lot of variation there after all. But actually very little data also we had, because only less than 1 year data. So it's difficult to make these sort of yearly, annual, seasonal effects or take them into account because of the limited number of data. So tested model, ARX model, for instance, because this is good baseline model, works rather nicely often when you dead rent or you stationize your data or time series. Dead rent it, remove the seasonal effects, period type of things, and take even some log transformation. So it means that it takes as an input of the time series, and then you have to of course optimize that how many time steps for the past I will use in my time series to predict the next outcome. This is the worst part of this. So where the I goes to 1 to p. Then we have external factors, if those exist. If they are numerical, they're very easy to add, and if they have a time component, that's also it's the same type of things that you're looking how many steps in past from this exogenous or external variable you're taking into account. Then you have a residual and of course constant, unless you are somehow put that to 0 mean. So this is a very simple model, but you have actually quite many parameters to be optimized. So this is the model complexity selection problem. You have to optimize the hyperparameters. This model is good in that sense that it reduces the overfitting risks because it's very simple. It's like a linear type of things, not that complicated. Captures core patterns and can also handle these external variables that you believe to influence the time series you are trying to predict. The other thing was this random forest. I favor normally this as a basic tool, especially when there are limited number of data, because in practice, although the theory is saying that it faces the same sort of overfitting problem than any other machine learning method, but in practice it's rather safe method. You can use it more or less like a black box. After all, we have noticed in quite many studies that this is one of the easiest models to avoid the overfitting. It's very robust to noise and outliers because of the ensemble thing, this boosting, XC boosting type of method. What is using handles nonlinearity, good properties like it provides naturally feature importance type of thing, so it can even evaluate what sort of features are important for making these sort of mappings. And also other thing is that it can at the same time handle numerical and categorical type of variables. When we have numerical model, we actually have to transform the categorical variables to numerical ones. How much time by type I have? Okay,
5-ish minutes.
Let me see. Okay. So then comes the performance estimation. You may also think that this is very easy. Nothing is easy actually in the data analytics machine learning sector. When you go deeper and deeper there, you are facing a lot of, I would not say difficulties or problem, I say challenges. So what is the main challenge in time series is autocorrelation. Because in almost all time series what you have, they have a heavy autocorrelation, meaning that if I have if I measure something now and I measure something after 10 minutes, the values are almost the same. It's like the weather. If you look 1 hour weather.
Can I challenge you already?
Yeah, okay, yes.
If you have like stocks or something that are...
That's a little bit different, yes.
But it's still
almost
autocorrelated because it depends on the previous value.
Yes,
because
there are.
It starts from the previous value, then it goes somewhere.
Yeah.
But if you're talking about sales like now, I mean the sales can really vary from day to day.
Yeah, from the database, but from the same day. It's not that big variance there.
Okay.
You can actually study that with autocorrelation function. Unfortunately, I don't have it here because I plotted it, but it happened that I prepared my presentation with the old computer and I thought that I have copied everything actually as a backup. My computer is now home, so I have a new computer without this autocorrelation function. So I prepared this presentation actually a little while ago, so it is missing something. But this is the way how you could study. You plot the so-called autocorrelation function, you measure the correlation between the samples. It actually very nicely shows this sort of effect. That closer you are to the current points, the better, often the higher correlation you have. And if you then use this sort of random type of evaluation, that you just select randomly some of the samples with the test and training, then these test and training sets has very high correlation, meaning that you will get overfitting. They will not work very well. The same thing if in all these type of spatial type of data, whether it is X and Y type like satellite images or time type of spatiality there like in time series. So how to address this autocorrelation? You can use this sort of n-fold rolling forecast forward validation type of methods, for instance, or adjust these performance metrics that account for autocorrelation structure. Like there are autocorrelation function of residuals. Also, this residual autocorrelation function shows that what sort of things you need to add from the history to your model to get it better. So quite many details. This is actually in this case study, I did the trending. I actually stationarized it. I had the models for seasonality and periodicity. This is easy. If you are interested, I can tell you later on this. So you can contact me how to do it because it's rather easy. It's like a unit circle type of idea. Optimize model hyperparameters with this sort of rolling origin forecast cross validation type of approach shown here. So you have first the training set in the beginning. Oh, sorry. This is the training set in the beginning and you forecast and then you increase gradually your training set and forecast. This is called, it's rather safe type of method dealing when you're dealing with autocorrelations. You can measure the mean absolute error and use that as a model complexity evaluation and having the best possible approach. But this of course was very simple case study with very simple data. Example results. This actually were the results. It was so that this AR model was a little bit, the performance was a little bit lower than what was this random forest. Random forest is actually very good method as a baseline method. Of course, now you may think why I didn't use this LSTM, etc. type of things, because we had very little data after all. And this was a preliminary type of study. More data, then of course we could use this. Example results like that. Prediction true values for a certain period. Also then we have hourly type of sales. They look what they look based on the data. You can go to up to a certain level with your data and that's it definitely. But of course, something can be predicted. Like there were quite many days where the prediction was rather good when it comes to the sales, prediction of the sales. Not that big difference after all. Also here you can see this sales per hour was certain period and sales per hour, like prediction and true values. Then a week ago seemed to be the best possible estimation, or actually the most important feature. So what was the sale? Sales 1 week ago is a good prediction what could it be today, and also the yesterday at the same time. This also makes sense after all. Monday, Friday, and Saturday, etc. Monday. Remember the trend, seasonality, periodicity was removed here. This is important thing to be done when dealing with time series. Okay, how to improve? Of course, lot of details. lot of work also means. So, like you always, if you want to improve something, you get actually rather nice results even with little effort. But then when you want to go a little bit more, you need to increase the work effort. I mean, really substantially compared to that what you have done. So collect more data, new data sources, like if there's a reservation data available, for instance, advanced feature engineering like public holidays, etc., observed holidays, school terms, specific meal periods, etc., and lagged variables. I just collect something here. And also weather data could be that one. Local events may be important, sport events, concerts. Of course, it's not that easy to collect these sort of things. Marketing and promotions, specific campaign start and end dates, competitor activity. Like in always, this is the thing that should be done if you want to improve your sales. No matter what is your business, restaurant or whatever you are selling, for instance. Or after all, we are dealing with the same sort of topics. So if you want to deploy this for practical use, this is okay, no, different story. So you have to, of course, integrate this type of, like nowadays people are talking about AI agents. Always some kind of terms are invented for old-fashioned type of things. This is the selling thing also there, that you had some new term, or actually old term. AI agent is very old term after all. It is from that era where first time in Finnish language we had the tekoäly term. It was agent-based type of things. Tekoäly agents, agentit. So automated pipelines, output delivery, integrating into existing system. Of course, these sort of things have to be just done. You have some IT system, you have to integrate the things there. Automation and scalability, retraining, more data comes in, you want to make the system better, update it, scalable infrastructure also. If your data volume grows substantially and business needs, you need to have a scalable infrastructure, monitoring and maintenance. You have to, of course, control how the system is working. If you see some abnormality, you should give warnings and do regular updates and something else also probably. But a lot of things also there. Now you may think that okay, nothing should be done because it means just more work, and if the results are not that good. But this is actually a fact with always in data analytics and machine learning, that you don't know the results before you try because it's database. You cannot derive, like in mathematics, you can derive of course the things often. So at least it was showed the potential of restaurant sales forecasting. But building a robust, interpretable and scalable system is not just a technical challenge. There are a lot of other things. It's also very small portion. We scientists are thinking that if we develop some method, that will change the world, or actually the life of the company. But probably it's only 1% of the whole thing, this method. This integration and validation and deployment takes so huge amount of effort that this algorithm is only more portion of it. Okay, that was my last slide. Any questions?
Go to questions. But before allowing more questions, I want to ask, what kind of actual sales data did you use? Are you allowed to say what kind of companies?
Rioni. So it's also in Espoo and Turku. Yeah.
I have a question. If this model would hypothetically be perfect, and it would perfectly predict the sales of the next day, how much would it actually change decisions of the restaurant? Like how much would they have this? How much would it impact?
Very good questions. I think because actually I knew this owner because I'm living in Espoo and she's from Espoo. So So I don't know to be rude, but I would expect that quite a lot when it comes to all these inventory type of things and optimizing the stuff and all these type of things. But of course you have to do this optimization also. It's not trivial thing at all. Because if you have an estimate about the sales, you have also uncertainty because this can provide the uncertainty. Then you should use some kind of Bayesian decision making under uncertainty to optimize the stuff and also the inventory. I know how to do it, but it's also the task that you have just to do. Then you can actually estimate that if you have this sort of whole process modeled, you can actually estimate that compare this in the probabilistic sense that what sort of improvements you can get, like how much salary weights you are actually saving with this sort of optimizations, for instance. But this has to be done. Yeah.
So opening times, whenever our model says that it's good for us to be open.
Yeah.
Can you just not use linear optimization with Windows or variables?
Smoothing, but this is like this, like infinity response filter type of approach. Yes, yeah, you can use that. Actually, what the random forest is more or less doing. So there's a window and predicts based on that. Yeah. Some of the methods are recurrent, but this is not. But very practical in it.
Any more questions? Mr. Jukka. Please address him, Mr. Jukka.
Oh, yeah, you can say that. So, if no, then I thank you.
Thank you. Great.
Hi all, a very good evening. My name is Anil. I am a tenured university teacher at the University of Turku Department of Computing. Today, I have an industrial collaborator from Nokia, Ikram Haq, who is a tech lead from the GenAI team. He's currently in Espoo, so we agreed to join via Zoom. So I will let him introduce the problem space first, and then I'll get into the details of it. It's a bit of a workaround, so I hope somehow it could be audible enough. I will text him to join now.
Says, let me share my screen. Yep, am I audible all right? And can you guys see my screen?
Yes.
Okay, sounds good. Thank you so much. Excited to join and cannot see you guys, but hello everyone. Myself, Ikram Haq. I am here for the AI Meetup to explain the problem and starting with a bit of introduction. Currently, I'm working as an AI lead at Nokia, and as you guys know, like Nokia is not making mobile phones anymore, but we are still in the telecommunication business. So what I do is mainly focus on artificial intelligence, trying to develop scalable engineering platforms and try to basically use those technologies to solve the problem in telecommunication business. We are a team of AI engineers, data scientists, and telco domain experts focused on trying to develop using LLMs and GenAI. We are trying to come with scalable, secure, and telco-native GenAI solutions. And the idea is to basically bridge a gap between the network or deep network industry and cutting-edge AI solutions that we are seeing at the moment. Going into a bit detail, what Nokia is looking for GenAI in future is what we are trying to basically, like any other industry, verticalize the GenAI platforms in telecommunication operations. We want to develop the applications that can help our processes in Nokia, our business at Nokia. We want to develop multi-agent systems that can do L112 for automation. L112 is basically some technical terms that we use in telecommunication industry to explain different issues of the network. We want to use LLMs or GenAI applications for design, for orchestration, for customer experience specifically. As you can see that if we develop a chatbot like ChatGPT or a voice chatbot that can help customers for customer care and stuff with our products, that will be an amazing thing. We want to develop scalable RAG applications and try to use LLMs for agents and try to feed in our own telco data on open source LLMs, which is Llama, Mistral, DeepSeek Llama, and many others that people have been or companies have been putting in the market at the moment. So what our main goal would be to have a system that is telco specific and models running in them that are telco specific to help Nokia's business. And I think there cannot be a better time than this, where tools are ready, talent is ready, and networks are complex. So let's combine them to do magic. As GenAI is not optional at the moment, it's inevitable. As NVIDIA CEO was saying in one of the talks that AI won't lose your job. The people using AI will basically get your job. So it's the best time to use AI. Going into detail, one industry is telecommunication that we are currently talking about. There can be other industries who are using LLMs or AI workloads on edge, on cloud, who are using AI models on autonomous systems, on surveillance systems, extended reality, and for diagnosis purposes in healthcare. All of these industries want to run AI workloads on some specific kind of hardware. And it can be any models, from very simple logistic regression to a large language model, all kind of AI workloads they want to deploy on some specific kind of hardware to have a scalable solution. So they try to use GPUs, CPUs, TPUs, or any kind of other accelerator from edge to cloud to run these kind of models. But the main challenge that comes into play is the efficiency and variance of different hardware and basically the efficiency that we lose when using this heterogeneous hardware for different sizes of models. And talking about the same problem from a very specific domain or with the glasses of Nokia is that we want to run from smaller models to Gen AI use cases like LLM workloads on these kind of heterogeneous hardware, which includes CPU, GPU, TPU, or any other accelerator. We want to deploy smaller computer vision models or even smaller classification models to LLMs. And the key challenge is that we have shared hardware in a cluster where a lot of other people are also using or consuming those resources. Sometimes bigger model can overwhelm the smaller model, and sometimes we want better efficiency on edge devices so that models can perform better there. So this is the main problem that I want to present that we are facing in the industry is that we need smart schedulers or hardware-aware or orchestration or better scheduling of these AI workloads on heterogeneous hardware so that we can be cost effective and we can work on energy conscious AI, because there are currently other runtimes including PyTorch and other open source stuff that are doing there, but they are not there yet or not that efficient because models are changing day by day, and now with LLMs we need better, smarter schedule for these kind of problems. So this is the problem we are facing in the industry, and that's what I wanted to present. And thank you so much. Over to you, Anil, to talk a bit deeper about this problem.
Yeah. Thank you. I will stop recording this meeting. Let me switch back to my... Okay, now I can actually restart from where I left off. So, my name is Anil. As I mentioned, I'm a tenured university teacher at the University of Turku and also a senior researcher at the Department of Computing. Ikram has nicely summarized the problem space that Nokia or many other AI-dominant industries are facing these days. I would like to take a step back and generalize the problem a bit more. That right now we have probably most of your AI experts, and I'm the least AI person in this room probably. What I notice is that over time we have extremely better algorithms in terms of AI, which have evolved from deep neural networks to a transformer with encoders and decoder that is in the Gen AI space as well. On the other hand, there is also exceptional hardware designers who have built efficient hardware in terms of having CPUs, graphic processor units, and multiple accelerators. But the missing piece of the puzzle is that we have exceptional algorithms and we have super efficient hardware, but there is a gap between finding the right match between the applications and the hardware, which is actually my field of research in general. There are some runtimes which come by default. For example, if you have used TensorRT or NCNN or cuDNN, etc., they provide you an API to do the basic scheduling, but they are not really. They are intelligent, but they are not really ready to use. For example, using TensorRT is like buying a flight ticket from a travel agency. It is very good, very comfortable, but then there is so much details behind that iron curtain that are hidden, which if you tap into, maybe you can optimize your costs per se. I will not really go into the details of AI because you're, as I said, more experts than me, but I have to start somewhere. I'll take a simple DNN example, for example, VGG16, which is pretty much widely used in plenty of object detection models. What I see here, what I see is that a couple of aspects that stand out or stick out to me is that maybe
the battery?
Yeah, I could do that.
Now it's gone.
it is good.
Yeah.
Should I go? Right. The key thing that sticks out for me in general is that there is a sequential data flow in most of the neural networks.
Okay.
Yeah, wait 1 minute, I put in new battery.
Yeah. Does this work? Okay.
Yeah, that works for outside. You have other models that do this work?
Wireless technology.
Everybody talks about AI. Please, somebody develop a powerless microphone.
An energy efficient microphone.
Screen on it so that you know how long the batteries will last.
Oh, that's the improvement already.
Or wires.
Yes. You're gonna go back to the wired time.
Yeah.
You try?
Can I hold it in my hand?
You can of course, if you want. Is that better?
Yeah, because it's in my eye line otherwise. So. Typically, this is the workflow of a more commonly used DNN. The first thing that sticks out to me as a systems engineer or systems designer is that there is sequential data flow, meaning that each subsequent layer is waiting for results from the previous layers. And then there is a significant amount of workload variation, meaning that through the lifetime of this application, maybe the inference lasts only few milliseconds, but then there is a huge amount of workload variation. That at the beginning we have these heavy convolutional layers, but as we go through time, the amount of computational intensity keeps reducing. Of course, in this example case, we have luckily a monotonous decrease so that it makes it slightly easier for the scheduler. The outcome of having sequential data flow and significant amount of workload variation is that it's not so obvious to schedule such applications, irrespective of however efficient your hardware is. So the problem that we are trying to solve is how to map a contemporary concurrent AI workloads, maybe some deep neural networks and transformers precisely, on heterogeneous hardware. Typical commercial heterogeneous hardware will include different types of CPUs. Maybe an ARM big little is a very good example of having a big and a little CPU. Some of NVIDIA's commercial products have a Denver and an ARM CPU clusters, followed by a GPU, for example, an Ampere architecture, and some accelerating processing units. For example, the boards that we work with, NVIDIA Jetson, has deep learning accelerator and vision accelerators. And Mac also has plenty of vision and streaming accelerators, probably with a different code names. The idea is that you could run CPUs for general purpose and sequential tasks, which are kind of a big core, which is really efficient in running sequential tasks in an energy efficient way. Whereas we have GPUs that are really good at running data parallel tasks, but extremely primitive in nature by the code itself. So sequential tasks will probably not do so well in the GPUs. And then we have domain-specific accelerators, for example, which have custom instructions if you would want to run a specific type of application from a domain, per se, for example, vision. And even Grok has developed a language processing unit in that sense. So the idea is that how do we take a workload that has sequential data flows, that has a huge amount of workload variation, and then a machine that exposes an extreme amount of power performance variation or dynamics in characteristic, and then map it in an efficient way without excessively or heavily relying on commercial or vendor-specific runtime managers such as TensorFlow or cuDNN. The first step is that we ran some of the widely used DNNs on an NVIDIA TX2, which has an ARM and a Denver CPU clusters and a GPU. I didn't touch the accelerator yet. We ran VGG19, MobileNet, ResNet, DenseNet, and efficient nets. Obviously, GPU always has the lowest possible latency because it's that much more powerful in comparison with the CPUs. So the trivial choice is that you always map your AI workload or a DNN workload on the GPU, which is what TensorFlow does by default anyway. But this solution works pretty well if you have one application that is running on your own machine, which is almost always never the case, right? Even on your mobile platforms, you're typically running probably one inference workload along with plenty of other background tasks. But more importantly, the use case that we are trying to solve is the multi-inference systems. For example, if you have an AR, VR gear setup, you are doing simultaneously localization, some kind of an object detection, and a gesture recognition. So you're technically running 3 different DNN models concurrently. Or if you can take example of autonomous or perception systems where you're trying to do an object detection, semantic segmentation, visual autometry, or obstacle avoidance, and plenty of other vision-related tasks simultaneously, probably working on the same image input data, for example. So the more emerging use case is to run multiple AI inference workloads at the same time. On the other hand, I can even quote a more recent example of if you're using any Gen AI tools when you're working, maybe this language model generator is also contacting other models to do maybe an image or a data analytics stuff probably. The point is that we want to run multiple AI inference workloads simultaneously, and it's not that obvious. And obviously we have shared resource contention, or so to speak, inter-application interference. So this is another quantifiable way to show that what's the impact of running more than one application simultaneously on a single machine, of course with different clusters. So on the blue, we have an application that is running in standalone. For example, the first one, there is VGG19 that is running standalone on the GPU, and we have a certain 0.4 seconds of an inference latency. But the moment we club it with another copy of another VGG19 on the green, there is an increase in the latency from 0.4 to per se 0.6. That's almost a 33% of increase in latency. And if we do the same thing on the CPU, then it just shoots up to 2.5 seconds already. So there is a significant penalty when you run more than one AI inference models on a beast of a platform, for example. Previously, we saw here that working on the GPU is the trivial choice and it's pretty much okay. But then why do we even need the other CPUs? So here is why we need the other CPU clusters. When you're running more than one application, you can map one of your more demanding applications on the CPU, but then you can map the other less demanding application on either of the CPU clusters. But the important or the interesting thing to notice is that there is, of course, a variation in the performance of GPU or a CPU, but then this variation is actually exclusively depending on the application characteristics itself. So for example, a mobile net doesn't really suffer by mapping it on a CPU or a sequential core, whereas a ResNet actually suffers a lot. So imagine that you have a combination of running a ResNet and a mobile net simultaneously, then you would want to pick ResNet to be mapped on the GPU and penalize mobile net a bit more for CPU because it can actually tolerate the latency damage. So this understanding the variation in workload between different clusters is actually the key for multi-DNN inference, which is what I'm trying to explore right now. The first step is to identify an application to core bias or application to cluster bias. That is, which kind of AI model runs how well or how poorly on a given cluster. Maybe an ARM CPU or a Denver CPU or an Ampere GPU or a deep learning accelerator per se. We can do that with a design time analysis if you statically know the system that you're going to run. For example, if it's an embedded system that is already deployed, maybe vision detection or robotics, where the application is known beforehand or the pattern, then you can do a design time analysis to understand which application is running at what latency, and you can create a static schedule so that it never changes at its lifetime. But a more challenging would be a dynamic workload. For example, the S-Market robot that we saw on Haminkato, maybe it actually stops when it faces some obstacle, which is that it cannot actually handle the compute intensity of too many moving parts. So it freezes practically. So this is the dummiest of techniques to make it more reliable or robust. That is to compromise on accuracy or the quality of the service. So in such a dynamic scenario, you would want to understand which type of model you would want to run at this point in time, understand what is the bias of that application towards which cluster, and then make a dynamic scheduling decision so that either it goes on the CPU or maybe on the GPU, considering that there is concurrently running other applications. One way to do this is to develop heuristics, for example, to get number of flops or the number of layers in a given model, and try to come up with a heuristic that if we have these many flops, probably it is going to perform in that at a fixed latency bound on a specific given cluster. One way to do that is actually to pass the ONX files of deep learning models, which is what we are currently doing at Utu. So we can understand the number of flops, the bias of each layer or the number of layers that are supported on each type of clusters, and then make an online decision as well. I will get into a very quick detail on how we can do this even further detailed. Earlier we saw that there is a specific layered architecture. Now the best way to actually parallelize this model is to split it up into multiple blocks. So we can imagine that this model has block 1, 2, 3, 4, so on and so forth. Each of these blocks are in decreasing order of computational intensity. So one of these blocks is definitely going to need more compute, for example, GPU, whereas towards the end, let's say block 4 doesn't really need GPU compute capacity, so maybe we can actually put it on the CPU. This may not make sense, or it may not sound like an efficient solution if you have one model, but now imagine that you're moving vehicle, like this is market robot, where you're continuously getting frames of images. So now we have to pipeline each of these blocks of each of these inferences, which is where it actually makes sense. So I'm going to use the GPU for my block 1 of image 0, and then free up the resources for the subsequent image. So then somebody else is going to use the heavier GPU, and I move to the CPU, making room for that. So this is pipelining of AI models, which has been pretty much, at least definitely an academic standard since the past 3 or 4 years. So the idea is that you pick the most intensive block and match it with the most computational capacity cluster, and then you subsequently move through the layers and then identify which cluster is more suitable for the compute capacity of that. So that we may not optimize the latency of a single inference, but we might increase or improve the throughput of a batch of 32 or 30 frames in a given 1 second, for example. The other technique we are trying to explore is dynamic block sizing. This is a bit more meta, I would say. Earlier we saw that we could map each layer to each cluster, which is a bit more fine-grained, but this also incurs a lot of data transfer between the clusters. So you need to spawn the engine and then go to the DRAM and then collect all the data back. So if there isn't if there is too much of data transfer between subsequent layers, maybe it is after all not such a great idea to trade off that. So what we can do is actually pack and bind multiple layers, sort of a subgraph within a DNN, and then schedule at a subgraph level. So the scheduling algorithm remains pretty much the same, but the granularity is now lifted from a layer level to a block level. So identifying the appropriate block might be, is the actual key component here. Another way of doing this, maybe there is 2 more ways, I would just wrap it up, is to partition the data. That is, we are operating on probably a huge amount of data parallel layers, maybe a matrix type of data, let's say 280 by 280 pixels. Now we can slice them horizontally, meaning that we create somehow data partitioning or data parallelism, and then spawn these many number of threads across the GPU clusters to improve or exploit parallelism out of it. The other way to do it actually is through mixing or combining both the vertical or the dynamic block sizing along with the horizontal partitioning, which is what we are currently working on, and we have recently published on first week of April on hybrid partitioning strategies. So right now we are trying to combine all these methods into a system software daemon or a middleware, I would say. This is the overview of the multi-DNN inference scheduler that we have designed so far. It's still not in its final stage, I would say. What we try to do is to do a lot of offline profiling, that is take multiple DNN applications, and we have at least 3 different heterogeneous hardware platforms in-house. So we took all these DNNs and ran each of them in different configurations at different voltage and frequency levels. And we are trying to build a PPO-based RL agent so that we understand what is the bias of within each DNN, what is the bias of a layer or what is the bias of a block towards which cluster in a given platform. And then make an online decision based on the observations that we have done so far. So the scheduling decision, I mean, whenever there is an inference request, the scheduler would actually find the appropriate cluster and the partitioning point for a given inference request and enforce the decision at the hardware level. Whenever there is this inference request that is happening, the scheduler would actually contact or create an RL inference request, and the RL agent is going to come up with the configuration settings, and the scheduler would enforce that decision onto the hardware. This was at least the basic idea. We have finished the data collection part and the RL agent design part. We have also deployed a preliminary version, but we haven't yet run all the results, I would say. A preliminary version of this is actually published, but we are now trying to make it as comprehensive as possible. So maybe in the coming 6 weeks or so, we might actually make a conclusive experimentation on this part. So this is a quick summary of multi-DNN inference scheduling that we're currently doing. But the more interesting or the pressing aspect that we were talking with Ikram and Nokia as well is scheduling. They were looking at scheduling language models, but I sort of annexed it with scheduling compound AI systems. So there is an emerging trend of compound AI systems where we have LLMs in the loop. Maybe LLM was pretty hot, let's say 3 or 4 years ago, but not anymore, I would say. Just whatever has to be done is already being done. But what's emerging is, for example, something like an alpha evolve, which is using LLM in the loop to write code or using chatbots that will interact with you by actually running some other models in the background to make a specific recommendation. So this is no longer a single language model generation, but an ensemble of multiple models behaving together in a chained fashion. For example, some of you might have heard about LangChain, which enables you to design applications from the scratch, which will spawn multiple AI inferences along with generative language models. The recipe is a bit similar. I wouldn't say the same, but it's a bit similar in the sense that previously we were looking at multi-DNN applications or multi-AI, but a multi-DNN, meaning that there is some level of homogeneity in the kind of workloads that we are dealing with, because most of them are task graph-based sequential data flow applications. But with the compound AI, now we have transformers as well. Some of them are generative transformers, some of them are maybe non-generative. And then we would want to run a transformer along with multiple DNNs, or maybe multiple transformers and DNNs in simultaneous fashion. And we have the similar hardware setup anyway. A couple of challenges that stick out with compound AI systems. The first one is that on the left we made a toy example of insurance management agency, which is trying to look at a broken piece of hardware, for example, a car, identify which are the parts that are broken and whether these are broken in a certain way and whether the insurance claim actually meets the standards or not, and then making some suggestions or interacting with the user. It's a fictitious case, we thought, which would be a reasonable to make an ensemble of multiple DNNs and transformers. But the first challenge that sticks out is that the workload variation earlier was at least a bit predictable, but now this is way too unpredictable, meaning that it depends on which compound AI will be generate over time is pretty much unpredictable. So it depends on the prompt, it depends on the nature of the prompt, the length of the prompt, and maybe the outcome of the prompt. And now the generative agent may or may not need a certain model to may or may not run on a certain set of inputs and then come back to you in the conversation. So this goes up and down, and the ebbs and flows are pretty much prevalent. So the first challenge that we found was the dynamic workload variation and the intensity and the unpredictability of which kind of inferences should we schedule in the coming time window. And the second one, probably if there is anything that I would want everybody to take away, is this that we faced, is the cluster feasibility. This is a simple fallback illustration from NVIDIA Jetson Orin. Jetson Orin has a couple of CPU clusters, one GPU, and then there is a deep learning accelerator, which is NVDLA, proprietary of NVIDIA. Most of us, or some of us, use the TensorFlow to schedule the applications on the GPU. Maybe we can also schedule it on the deep learning accelerator. Deep learning accelerator by default is the name suggests acceleration, but it's not really an acceleration. It's more of an energy efficient or energy conscious scheduling of the deep learning workload. The problem is that not all the operators on all the AI models are actually feasible with the deep learning accelerator. And whenever the system encounters an unfeasible or unsupported operator on the DLA, which is the deep learning accelerator, the execution silently falls back onto the GPU. So maybe you might schedule a transformer on the DLA and you hope that it's running in an energy efficient fashion or maybe even in a faster fashion, but you will not even notice what's going on, that most of the operators on transformer models are not supported on the deep learning accelerator. So then these are falling back to the GPU. So you thought that your GPU is actually free, but it is not. Whatever is falling back to the GPU, and now the GPU has to service these unsupported operators. The interesting thing to notice is that we ran 4 different applications, both and with transformers, ResNet and VGC DNNs. You could notice that with the DNNs, there is a huge amount of operator support for the DLAs. So you can freely run your DNNs on DLA and hope that it actually works out better. Whereas if you look at the transformer models, birth-based and width-based, there are numerous occasions, for example, with width-based, there are unsupported operators on the DLA, and every time it falls back to the GPU. The number of instances at which it falls back to the GPU are pretty high. As opposed to, for example, birth-based, there's a huge chunk of operators that never actually is supported on the GPU. So it is almost practically executing on the GPU and not on the DLA. Now, this information it's I wouldn't say it's hidden, but this is not so obvious or trivial unless you actually run a practical test experiment to find out for yourself. So if you would want to run a compound AI system, that is you have an LLM plus some other models, you have to practically assume that the accelerators are dead for the transformer models. So now your scheduling decision becomes a bit more specific or pigeonholed in that sense. When you're running a combination or an ensemble of a DNN and a transformer-based LLM, the ideal way to go ahead is that to understand the bias or the feasibility of operator support for each of these models, that is to find the number or the volume of operators that are supported on the DLA or any other accelerator that is existing on a machine. And then based on that, make your scheduling decisions that you might turn this problem space into an opportunity, that you would schedule all of your DNNs on the accelerators, and you would simultaneously schedule all your transformer workloads on the GPUs. Maybe you might also want to encounter or take into account the penalty of these fallbacks, for example. So we are trying to build an ensemble scheduler that will understand the application to cluster bias, layer to cluster bias, impact of dynamic block sizing, feasibility of running a specific kind of operators on a specific cluster, and then the penalties of running them simultaneously. And we are also looking at a mobile GPU sharing through NVIDIA's MPS as well to do some resource stealing ideology. This is a preliminary version of the scheduler that we are designing for compound AI systems, where we have multiple applications. For example, we are looking at the ONX format of each of these applications and trying to extract or parse the information on the flops that are needed by the application, the number and the volume of operators that are supported on a DNN, on a DLA and a GPU. And then we are trying to understand information from a platform's perspective that, for example, we have Jetson Orin, but maybe some other platform has a different kind of an accelerator, for example, an NPU. So we are trying to come up with a platform configuration file and then try to match the application's compatibility with the platform's compatibility and come up with a layer by layer schedule for each of these applications in conjunction. So that we can do an ensemble mapping in the end across the CPU, GPU, and the accelerator clusters as well. In our case, we are testing with the NVIDIA's NVDLA accelerator, but some of Google Pixel platforms have NPU and some of them have TPUs. The only nuance that we found out, or we came to a conclusion at our team, is that most of the accelerators are designed, say, 4 or 5 years ago, when DNNs were pretty much hot, but not yet the transformers. So maybe the hardware is slowly emerging towards transformer-supported accelerators as well. But right now, the commercial hardware that I have come across is not really supporting the transformers. So this, which makes an intelligent scheduler that much more important at this point in time. We have implemented the schedulers on and deployed them on NVIDIA Jetson TX2 and NVIDIA Orin HGX, and but this is still unpublished work, so I didn't include any data or results. Hopefully, maybe in the coming 3 months or so, we might actually run the real experiments. But at the same time, it would be anyway. The scheduler really works, and the results are pretty good because we are competing against an absolute baseline, so it is going to be better anyway. And one last thing that I actually missed across this entire topic is in a way, it's also incidental that we have also included an energy efficiency component in this one, that in our scheduler, we conjoin the decision of dynamic voltage frequency scaling and CPU quota assignment or the time slice assignment. But it gets pretty nerdy at that stage, so I would leave it at this point. But our scheduler is also energy conscious or energy aware, if that's relevant for the audience. I'm actually 2 minutes over time, so I would stop here and welcome the floor for your comments. And before I finish, I also would like to thank Kai and the team.
Jani, yeah.
No, I wanted to remember the name at VSKT.
Yeah, that's good.
I would like to thank all the good people that have assembled here.
And Vaadin, yeah.
And Vaadin for arranging this, and also most importantly my colleagues or PhD students at Tutu, Zain, Tafiq and Aman Vyas, who is actually the force behind all the ADS that we are implementing, and also to Ikram Al-Haq from Nokia for contributing and collaborating with us. And have a good evening. I will open the floor if you have any comments.
Thank you. I will start with a question. How close are you to implement this for Nokia?
For Nokia, Nokia has a different, the problem is similar but not same, in the sense that Nokia is working exclusively on cloud native applications. So they don't have too much control on how much you can tweak with the scheduling itself. So we took the problem and resurfaced it to an edge platform where I have more control on what I can implement as a middleware. I think at least I don't know the nitty-gritty of which provider are they using and which exact specific variant of language model they are using, but in general, this is what they are doing, so to speak.
Really interesting. Must be one of the most technical talks in a while. But how much of the code is like custom? Is it like, can you use something for the scheduling part? Are you doing a custom library, or are you using something, or
This started when I was a PhD student at the final year. So at that time, I implemented a wrapper around the Linux scheduler. So I implemented, my scheduler is a user space process which is written in C++, but it interacts with the Linux scheduler and overrides the decisions by using the shared memory mechanism. And after I graduated, and now when I started supervising PhD students, they hated using C++, so they are using Python sys library. So
surprise.
So, but
is it open source?
It's not yet. Hopefully, if they graduate, then maybe that's the last thing that I'll ask them to do, to open source. So not do it when you're still in the race. So
yeah.
Can't do that yet. But the idea is to create a library and create an API such that it can be open source for everybody, like without even knowing. You can fly without knowing how aerodynamics works, for example. So, this is meant for AI ML experts who doesn't have to care about the hardware.
Another question, if there's time, then the heuristics of the different layers, are those like generated automatically, or are those like manual? Or like, is there some sort of prioritization between the different layers where to like toss them?
Okay, we are currently dealing with a different kind of prioritization, that which application should be prioritized first if there are multiple of them. But when it comes to layers, then it's a bit application specific. for example, if we have time critical, time sensitive applications, this always gets the highest priority. If that is not an objective, if latency is not too sensitive, but throughput is pretty important, then we would always by default go with the energy efficiency, meaning that the ratio of time taken to the amount of power consumed or energy consumed. So that those layers, so whichever layer is doing pretty energy efficient job on whichever cluster, that would be the primary choice, if that's what you prefer. For example, it's more about a real life use case of mobile user applications, that if you would want a 4K video game, then you would actually you're very happy to burn the energy for that. But when you're lost in the woods and you would want to save the energy, then you don't really care about any of that. So you would put it in energy mode. So we actually have 3 different modes right now that we can operate in a performance mode, where we will always prioritize the fastest, the latency, meaning that the strategy is race to idle. Then we also have energy efficiency mode, where we try to pick the target that is giving us better performance per watt. Then we have a robust mode or an accurate mode, where we try to always run the highest variant of accuracy of a given model, because we have configurable accuracy levels of different models, and we have been exploring that as well. So if you don't have a huge requirement on accuracy, then we were actually running, let's say with MobileNet, we were running somewhere between V0 to V7. You could pick the V7 being, for example, the least accurate model, which gives you a huge amount of a super good latency and very little power consumption. So, but then are you willing to trade off that kind of accuracy at that point? One use case is a smart building or a smart surveillance, where you would want to designate specific areas where you would want the highest accuracy of object recognition, where you have some other rooms where you don't really need so much. So this we have actually implemented, and it is published as well. So this is open right now. So it's accuracy, performance, energy, co-optimization scheduler for multi DNN vision applications. Anybody?
Just a small question.
Yes.
So you mentioned the deep learning accelerator and the transformer functionality. Is that similar to FPGA prototyping?
It depends on what's the accelerator that you have used on the FPGA. So if you are designing a custom code for yourself, the application that you are designing or targeting, then obviously you would design it in such a way that it supports your targeted application. So I don't see a huge problem in that. But NVIDIA's DLA is supported for DNN type of deep learning applications, whereas a TPU is supporting tensor operations. But whether do you have those predominantly those operators in an emerging generative transformer, that remains to be seen. So that's why, in our experience with this transformer workload, with that NVDLA specific piece of hardware, we don't see a huge gain, which I also assume that is pretty much the same with a TPU or a NPU as well. The common consensus that we had in our team is that in terms of hardware, they were designed few years ago when the first thought of accelerating came up. At that time, transformers were not so proliferative, probably, at least not generative language models. So then, if you want to use commercial existing hardware and you want to use you want to use hardware that's new, but the thought for this hardware came 4 years ago. But the model there is a new release every 3 days. So there is a gap here. And then if you want to make the commercial legacy hardware more, if you want to put that to job, then we might need some intelligent way to do that. If there is I'm pretty sure that within 1 year or so, maybe there will be a commercial language processing unit, and then it might be more seamless. Please.
Yeah, what would you say is a typical hardware utilization level on one of your compute nodes using your scheduler? Because I know that has been a big issue in the past.
This is an issue particularly with the GPU, for example. This is an issue particularly with the GPU of NVIDIA, let's say, because it's a lot more closed. We tried to run an extreme amount of combinations to find out how to actually populate the entire GPU cluster and track the information. One way to do for us was to run a really large model. For example, we were running Gemma along with other vision models, and then we are getting a huge amount of, the GPU is always busy and full. But then if you're running a simplistic model on a monster of a GPU, then you're getting GPU underutilization. So at least the space that I work in is mostly mobile edge, and here we don't have ideal GPU at all, as opposed to a cloud native application where they don't efficiently use a multi-node GPU, and then they have these phases of a huge amount of traffic followed by no traffic at all at some point in time, but then you're actually virtualizing the entire container, and then you're wasting 80% of resources for 60% of the time that you're buying the cloud resource. But then this is a different problem space for us. For us, it's always been the highest possible utilization. So we have a daemon that will automatically scale if we do not have so much utilization, then we actually reduce the voltage and frequency to drag it such that the utilization doesn't really cost you power. So it's a choice. Usually we try to race to idle so that we finish the task as soon as possible and then put the machine to sleep and power it down so that we save the energy during the rest of the cycles. So in that case, we are either having a very high utilization when we are active or having a very efficient utilization when we are passive with a lower VBFS. But we tried to do this, that we can control the streaming engines of NVIDIA because they have an MPS API. But then this is, at least in my experience, it behaves in a pretty, I wouldn't say weird, but it's very hard to understand why am I not seeing what I pin. For example, there are 8 streaming engines in the Ampere that we have. We tried to set the utilization, for example, at different ratios from 10 to 100. But then there is a black box NVIDIA scheduler which will override my decision. So when I try to run an application to expose a suboptimal situation, it doesn't even allow me to do that. So whatever scheduling decision I make, just to see the efficacy, NVIDIA hardware scheduler is probably overriding me and making the best decision in that circumstance. So it's a bit difficult to understand or showcase the impact of poor utilization, etc.
Thank you.
Good evening, everyone. So I am Moshini Veerakoot, and I'm a first-year PhD student.
Yeah. You can keep your hand.
Yeah, that is easy actually. So I just started my PhD, so I wouldn't be having any groundbreaking results to show, and I hope you will ask me hard questions so I can probably take them into consideration since I'm in the beginning of this particular research project. So going into the background, so my research explores how generative AI, particularly large language models, can transform requirement engineering in software development. This might be very different to what from the talks that we had been having so far in this evening. So the goal is to basically enhance the efficiency and effectiveness of requirement engineering practices. And is there anyone from the audience who have been or had been working with requirements at some point? Okay, that's quite nice. So I will be having probably a lot more input in the Q&A session from you guys. But feel free to join in and give me some inputs here. So, so we talked about having in the previous slide about enhancing efficiency and effectiveness, which is like a very broader term. So what I'm planning to do here is minimizing some of prominent failures in requirements. And in this paper that I pulled from the literature, there had been the mentions of a couple of most prominent requirement failures. So if you had been ever encountered with a client, you know sometimes how difficult for the client to express what they need and how difficult for you to understand what the client needs. And then once it comes to the stage of building it, transforming what the client told to the development team and to the testing team, that is not very straightforward. And sometimes the cost of not doing this right happens it costs big in terms of time as well as resources. It costs. So with that, in the light of those challenges, although there had been the mention of 4 requirement engineering phases, in my PhD, I am not still quite sure whether I will be able to explore all 4 stages in full. And we are still figuring out some of the scope changes in my PhD. It just started in January. And also currently the plan is to consider multiple LLMs and to be the tryout tool in here, which we will be discussing in the next few slides. And the last sentence might not interest you, but this is a qualitative exploratory approach I'm taking here, but this could also include the design science approach. So you can just ignore that part. It's more for the academics. And there will be the building of the tool will be led or will be supported mainly by the survey findings and industrial feedback, because I wouldn't want to make some kind of a tool in the academia and the industry wouldn't have like any proper use of it. So one task of my PhD is getting on board some of the companies or places that are running these requirement engineering related tasks in their software development life cycle to support with the piloting of the tool and the related development. And the last part includes the deliverables I plan at the end of this project. And these are the research questions I try to answer at this point of my PhD. So the possibility of large language models to conduct requirement engineering phases. So this kind of a research question we answer with usually with a literature survey to going out to see what academics have done so far, and also with interviews and surveys. And the research question 2 explores about the development part, and research question 3 this kind of stems out from the research question 2, and it tries to tries to cover the rest of the phases in requirement engineering. The research question 2 try to see the elicitation phase, but analysis, management, finalization, those phases would be covered in research question 3. But this largely depends on the timing of the timing at my PhD, how much time I would have been left after I done the research question 2. So this is the research phases. This will shortly be followed up by a planned timeline of the PhD to get you some idea. So this phase 1, phase 2 and phase 3, you can see how I have been planning, starting with the literature review and industry survey and development, and then validation through the survey and user testing. So the onboarding of interested industrial parties is what I need for phase 2 and phase 3 for the continuation of the development. And the timeline supposed is like this. The expected end date is 2027. So until then, I have few milestones to achieve. Me and my supervisor, we will work hard to make this a reality. So the current situation, so this might be the most interesting question or the slide. So currently I'm in the phase of conceptualization and survey study, and I will shortly begin tool building. I want to wait until the survey is done to start with that. So it will be projected date is July. And the phase 3 is not planned for now, like at which around a month. I can't give an exact month. For now, it depends largely on the building of the tool, what I extract from the survey, and what else I would need before going to phase 3. So I have been talking with a couple of companies, and there have been a couple of green lights also for them to help me with the initial piloting, as well as being the to go with the interview rounds. I am putting a more focus on survey study here because as I am working on getting people in to answer the survey, especially the requirement engineering practitioners. So the goal of this survey is identifying the current practices, challenges, as well as perceptions of using generative AI tools, whether you have been already using it or you are planning to use it, or what you think about it, basically. So the methodology is quite straightforward. It's a survey and interviews with stakeholders from within Finland as well as international software companies. And the international relations would come from my own personal contacts. I have been working as a senior business analyst before coming to Finland, so I have the planned prospect of grabbing some of my friends to answer the survey. But the piloting of this particular project will happen only within Finland as of now. And this phase 2 is where the building of the tool, I will be first working with more than one LLM, and mostly it will be an in-house training of an LLM without using APIs. And we have a couple of options for that. And recently the University of Turku grabbed a very decent GPU, so we will be able to train some of, for example, DeepSeek. We are already trying with that in other projects. So we will be able to work on a certain model that could be built in-house. And also I am seeking for the probabilities of particular companies wanting to try the model in their own servers. So we will see how it goes. And the expectation is the tool will be largely generalizable without a lot of customizations, because in terms of requirement engineering, it is not straightforward and it is not like a set of activities that all the companies follow in order. It depends on company culture, the type of projects, also the type of the industry that the projects are in. So there are a couple of those I would say not limitations, but aspects that I had to consider, which I plan to grab through the survey. And there had been some interesting experimentation we have been doing so far, and I have grabbed some screenshots to show you here. So this is, you might wonder, and I'm not sure if it really readable. I may have put like a bigger image, so sorry for that. But how this has been generated, I can actually show you a better image probably. Let me see if I...
There's also like a slight problem with the autofocus on the projector. Okay. So.
Yeah. I don't think then it would be readable even. Yeah, so this is, you can see this is a simple HTML file. But what does this say? So, user stories, they are like most popular and most used way of defining requirements. And we, in this particular tool that we built, so this is you can say this is like a part of the main tool. This is not the tool that I am supposed to build. So part of the tool, this one, when we input the first, if you see the first 4 user stories, the tool itself generated this particular flow. We call it post-it flow because it's like these post-it notes. And the use of this is we used GPT-4 API for this. We asked the API to add additional entity relationships, stakeholder relationships, and server communications, and also additional entities from whatever you can grab from that 4 user stories, and put it in an order, and also introduce more stakeholders if not mentioned. So yes, we have to give some context background for API before coming up with something like this. It is not exactly straightforward to give just the 4 user stories. And all these information were added by the API after the prompt, after we had it prompted, and this was first created as a YAML file, and then we generated it to be in HTML file. We plan to make it interactive. So the purpose is, once you grab like requirements in very first stage, it takes some time for it to be documented and come to a process of understood by the developers or the testers. But we plan to make it develop a little bit more interactive in a way that the later users of user stories getting like a better overview of the system that is being developed. So this might not answer exactly all my research questions, but the plan is to try out the possibilities of requirement engineering within the capabilities of AI. And this one post-it note is like enlarged image. So you can see it gives like some idea about what this customer does and how the interactions with rest of the entities happens. And we are writing a paper about this work, and we hopefully planning to make a publication if it is accepted. And phase 3, this will not commence until phase 1 and 2 are completed, because for us to go to the testing phase, we need a lot more information and a more developed version of the tool, and we will come across. And I also plan to collaborate with I'm not sure if I can say the names of the companies, but so those companies might have their own restrictions. So phase 3 will mostly adopt based on phase 1 and 2. And challenges so far, use of AI models in commercial setting always brings these in coherent challenges in-house. So that's why the local training of LLM-based assistant comes into the discussion and as a requirement of this project. And onboarding companies to pilot the tool or at least answer the survey. And yeah, so these are few information about my PhD and this research work, and there is no research group in the University of Turku for this particular PhD now. So I will be also collaborating with Labranta University with some of the academic professionals there and the companies that I am collaborating with. And so the survey I have been in the process of it will be live in couple of days or hopefully weeks. It's gonna take time for me to drag it here, but yeah. So it's on, but it is almost done, but my supervisors didn't give me still the green light. So this survey, this will be live, and I would most certainly hope that if you would like to register your interest to answer this survey, that I am mostly pleased to send it to you, and you can answer it if you wish, and your answers will be taken into consideration in the beginning. So please, if you like, scan the QR code and enter your email, and I will send you once the survey is out and live. And that is it. And if this is my information, my university email as well as the LinkedIn profile, and I would be most thankful for giving me the chance to speak in here, since I am very much in the beginning of my studies. This is really a good opportunity to have build the connections and get the support for the pilot study. So yeah, that will be the end.
We'll open up time for questions, but I start with one. What is to be gained for the company's perspective if they participate in the survey or participate in your research? What is their gain in the end, you think?
Okay, so it will be voluntary for them to participate in the preceding interviews after the survey. But the survey, what is their gain? So I believe if a company is interested in to see the ways of how these new AI developments could have made some of their workflows more easy. We don't talk about like replacing humans in the loop here. We talk about like assisting humans. So that's something I want to amplify in my research. So I believe the companies are having certain problems that they want someone to investigate, but they do not have some dedicated workforce inside the industry, inside the projects, etc. So grabbing them and trying to find solutions may be what academics like us can do, and but doing it on our own without having any insights from the industry just make us do like something less useful. So I believe if somebody from the industry find this kind of thing particularly interesting, this would be a chance. And also we will be open to piloting this tool once it is done to the companies that have answered the survey, if they wish. And also my plan is, I don't think all the companies who will answer the industry professionals who will answer the survey will be open to have something like this piloted. So we will be having some interviews to get the interested parties. So we will have like a more customizable version for them. So that will be the takeaway for them from answering the survey.
How far do the generated requirements go? Like how far are you planning to take them? Like user stories or even technical requirements or?
Yeah, so when I started my PhD, I told my supervisor I want to make the entire cycle automated. But my supervisor thinks it's a little bit too far of a target given 3 years needing to pilot it and getting some feedback. But I will try my best to do like the entire loop automated as much as possible. But for now I am planning to start with the very first interaction level that the client will have with the professional. And because there have been some tools that is coming up already which can come up with these user stories just by a call to an API, and likewise it's only like these tools are there, but they do only a particular set of tasks. There's very less, or I haven't found any tools that will do like majority of the task in one go. So it is like I don't particularly support the idea of using thousands of tools for different tasks. Although LLMs have been having a lot of attention lately, it doesn't mean like you should use all these tools just because they are LLM based. And for now, the realistic task for me is to try to automate from the very first interaction to the documentation part, and also trying to come up with the interfaces and mockups part. The technical part, and I have a feeling it wouldn't be like a lot unrealistic situation, but also depends on what my probable clients expect for me. So I have to find a balance between that as well. So yeah.
Okay. Any other questions?
No, thank you.
Yes.
Thank you.